These series of videos are the Hydrate post-lab discussion. We'll be looking at what hydrates are, the dehydration equation, calculations from lab, how we can figure out our expected results, any errors, how we can determine errors that were made, and then looking at the graphs. So a hydrate is an ionic salt with water molecules trapped in the crystal lattice. The hydrate that we used in lab was MgSO4.7H2O. This little dot here tells you that the water is trapped in with those crystals. So this whole formula is the formula for the hydrate. If I was going to name this hydrate, we would name the ionic salt just like we normally would. So this would be magnesium sulfate. And since it has 7 waters, we call it a heptahydrate. We call it a heptahydrate. So if I had 1 molecule of this hydrate, I would have 1 molecule of MgSO4, and I would have 7 molecules of water that are trapped in there. Now, if I multiplied both of these by 6.022 times 10 to the 23rd, then I could replace this that for every 1 mole of magnesium sulfate, I would have 7 moles of water. All right, so what we're going to be looking at with calculations is how many moles of water did you get in your lab to every 1 mole of magnesium sulfate. All right, let's look at this other hydrate. And you may remember this hydrate. This was a hydrate that we used in the chemical and physical changes lab. So you heated the blue crystals, they turned white. And then when you drove the water off, and then you could add the water back in and they went back blue. So if we were going to write the formula for this, copper 2, that's a copper with a 2+ charge. Sulfate has a 2- charge, so that is neutral. We have this dot telling us that we have some water trapped in this hydrate, and because of the penta, we must have 5 waters. Right, so the process that you did in lab was a dehydration process. That's the process of removing the water from a hydrate, and it produces an anhydrate. So you really start with your hydrate, and then you form your anhydrate and some water. All right, so if we took the copper sulfate pentahydrate, right here, copper 2 sulfate pentahydrate, if we dehydrated it, we would free up the copper sulfate and release 5 moles of water. Now you may see some little, the little S here, and the G. That's telling you the states. So the copper, our hydrate, our copper sulfate pentahydrate was a solid to begin with. When we formed the anhydrate, that anhydrate was still a solid, and the water became a gas. So this is the dehydration reaction that we are looking for, what you did in lab. So If you completely dehydrated your hydrate, you would release a total of 7 molecules of water or moles of water. If you didn't get all the water out, then you may have some water left. So you would have still started with your heptahydrate, but when you got finished, you would have had a dihydrate and released only 5 of those waters. So we're trying to figure out what that value is. So the next video will go through the calculations.